Okay, in lesson 3.6, we are talking about, officially it's theorems about roots of polynomial equations. Officially, we are learning something called the rational roots theorem. Okay? The rational roots theorem, and we'll make it make sense, okay? This is the, I tried to make not too official, but give you the information.
Yeah.
Given a polynomial, all possible rational roots, what we call PRRs, possible rational roots, can be found by taking the factors of the constant coefficient, which we refer to as P, divided by the factors of the leading coefficient, which we refer to as Q. So in other words, x equals P over Q. The idea here, okay, it's going to be factors of the constant divided by factors of the leading. That's going to be the key you have to remember. And what is this going to do for us is it's going to help us find possible factors. They won't all be factors, but it's going to help us find the possible factors because we're finding possible roots. And this can help us eventually find all answers, which is what we will be doing on the second part of this. So right now, we're just going to talk about being able to identify possible rational roots, or in other words, PRRs. So we're going to go through, and we're going to use that idea of P over Q, and we're going to find just possible rational roots. We're not going to go any farther. We're not going to check and see which ones work and which ones don't work. We'll save that for later. We're just going to find possible roots. So, officially, it was x equals P over Q. Now, what did it say P was?
Yes.
P is going to be factors of the constant coefficient. Where is my constant in this problem? What is my constant? What do I mean by the word constant? What? Negative 8. Why is negative 8 the constant?
Because it doesn't have an x.
Okay, it doesn't have an x, right? So we're looking for that term that, if written in standard form, does not have an x. So this is my constant. So on top, we're going to be looking for factors, and we'll talk about what they are here in a moment, but factors of negative 8. Okay, that's what P is going to be, whatever factors of negative 8 there are. The denominator is Q, and that's factors of the leading coefficient. It's my leading coefficient. This one should be
4x4.
Why 4?
Because it has the biggest whatever it's called.
Okay. So 4x to the 4th is our leading term, right? Because it has the highest power, exponent, degree, whatever word you want to put in there. The coefficient is a number out front of it. So specifically, it's the big 4 out front of it. It's not the power. So in my denominator, I'm going to be doing factors of 4. Okay. So, factors of negative 8. Or don't even worry about the negative for a moment. What are factors of 8? As in, what numbers multiply to be 8?
2 and 4. 4. Yeah.
Okay. So if we talk about what numbers multiply to be 8, 1 times 8 is 8. 2 times 4 is 8. Any other pairs?
No.
No. Now, officially it says negative 8 here, right? So
Negative incredible.
it could be a negative 2 times positive 4. It could be a positive 2 times negative 4. The factors can always be negative as well. So on all of these, we're going to say plus or minus. So I'm going to list this as plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Okay, those are my factors of the constant.
Yeah.
You always say plus or minus in front of all of your factors. Okay, in the denominator, factors of 4. What numbers multiply to be 4?
1 and 4, 2 and 2.
1 and 4, 2 and 2. Anything else?
No.
No? Okay. I tend to go in numerical order, so realize I'm going to say plus or minus 1, plus or minus 2, and plus or minus 4. Now, we're not going to leave our answer like this, because this isn't really a list of all of our possible rational roots here. This is kind of how we can come up with all the possibilities. Because basically, how do I want to explain this? We want to go through and put all the combos together. In other words, everything can go over 1. 1 can go over 1. 2 can go over 1. 4 can go over 1. 8 can go over 1. Yes? Everything can go over 2, and everything can go over 4. Or you can do it the other way around and say, okay, everything over, the key is match up every numerator option with every denominator option. So when I go through and do that, okay, 1 over 1 is going to be what? 1. Still going to be plus or minus. Okay, so there's 1. 2 over 1 is plus or minus 2. 4 over 1, plus or minus 4, and 8 over 1, plus or minus 8. Now, I tend to repeat the process, put everything over 2. So 1 over 2 is going to be plus or minus 1/2. What about 2 over 2? It's 1. And what do you know about 1? Did I already list that?
Yeah.
Do I need to list it again? No. Okay. So we did 1 over 2, 1/2. 2 over 2 we've already done. What about 4 over 2?
2.
That's 2. Did I already do that one? Okay, I don't need to list it again. What about 8 over 2?
4.
That's 4. Did I already do that one? So I don't need to list that one. Okay. Now we're going to take turns putting everything over 4. 1 over 4? Plus or minus 1/4. I haven't done that one yet, so I'll add it in. Let's see, what do we say? 1 over 4, 2 over 4. 2 over 4 reduces to be 1/2, and didn't we already do 1/2?
Yep.
Okay. 4 over 4? 1. Already did that. 8 over 4? 2. So right here is my list of PRRs. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 1/2, plus or minus 1/4. Good news? It doesn't look like you have to type those all in when you're doing Savas. For me, yes, you would have to write those all out. Okay, you can expect to see something like that on the quiz or test. But for Savas, it's a multiple choice. Now, keep in mind, when they do theirs, they say positive 1, comma, negative 1. Positive 2, comma, negative 2. So they don't, on Savas, I noticed they didn't put plus or minus. They left the positive number, then the negative number. So just be aware of that, okay? To me, I'd rather write it out like this, though, if we have to write it out by hand. Okay, questions? We're going to use this skill down below, okay? But right now, we're just kind of working on this skill. Okay, you ready to try B? We're being asked to list all possible rational solutions. I should have made that roots right there. So, PRRs. Officially, I'm going to tell you to think X equals P over Q. But, most importantly, it's factors of what over factors of what? So P. P is factors of my constant. What's my constant here? Negative 45, because it is the term without a variable. Does the constant have to be the last number? Not necessarily. Will they always be provided to you in standard form? Not necessarily. Okay? So factors of negative 45, because that is my constant, over what? Factors of, what's my lead? 7. Okay. Gonna make your brain think a little harder. Seen some calculators come out as we double check things. Factors of negative 45. Don't worry about the negative, just think factors of 45. What pairs you got for me? 9 and 5? Okay. If you know factors of 45, if you know your basic factors up through 10, 9 and 5, it would be a pair. What else?
3
and 15? That's probably the challenging pair, if you ask me. The pair you're going to have to think a little bit. You're overlooking an easy one. What's an easy? There's always 1 in itself, right? So 1 and 45. If it's divisible by 9, it has to divide by 3. So 3 and 15. 5 and 9. Are we missing anything? And here's how I'm going to check. Okay. We've got 1. Does it divide by 2? No. And if it doesn't divide by 2, guys, here's the trick. It's not going to divide by any even numbers. If it doesn't divide by 2, you can forget about trying any more evens. We already talked about 3. 4 is even, so strike that. We already talked about 5, didn't we? 6 is even, strike that. 7? No. 8's even, so we don't have to worry about that. And 9, didn't we already talk about 9? Right there, 5 and 9 is a pair. So I just have to finish listing the others. So it's 3 and 15, 1 and 45. So kind of some tips to make sure you get all the pairs. Don't overlook pairs. What about factors of 7? 1 and 7? Nothing else? Okay. Well, it's kind of good news since we have so many on top, isn't it? So, okay. Write them out. I don't care what order you put them in, as long as they all make it there, right? So if I put everything over 1. 1 over 1. 3 over 1. 5 over 1. 9 over 1. 15 over 1. And 45 over 1. So that's plus or minus each of those numbers. 1, 3, 5, 9, 15, 45. What else do we need to do now? Everything over 7. So plus or minus 1/7. Plus or minus 3/7. Plus or minus 5/7. Plus or minus 9/7. Plus or minus 15/7. And plus or minus 45/7. Okay. That's a lot right there, isn't it?
Yep.
Now, good news though, you're not being asked to do anything with them. You're just being asked to practice listing them. Okay? So these are the possible rational roots, your PRRs. Okay? So these are the rational numbers that might be answers to this problem. At most, what? It's 7x to the third, so at most 3 of these are answers. That's if all of our answers are rational. Okay? So we're going to use this idea of PRRs to help us find the actual roots to a problem. So this will be our starting point on the next couple of pieces. Okay, ready for the next part? As you start to look at the next part, notice it says, what are all of the complex roots of the polynomial equation? and then write the polynomial in completely factored form. When it says all, it wants anything that's rational, anything that's irrational, and when it says complex, that's hinting that there could be some i's, right? There could be some imaginaries. Okay, so what are all of the complex roots? Your starting point is your PRRs. Okay, if I think about trying to give you steps, so to speak, on this problem, step 1 is to find PRRs. PRRs. So when we go to find our PRRs, what we just did, factors of what over factors of what? Factors of, what is my constant? -2. I'm trying to keep this up to the top because there are several steps to do in this problem. So factors of -2, because that was my constant, over what's my lead coefficient? Factors of 3. So right there, guys, the -2, the 3, and that's because it is in standard form. What are factors of -2? 1 and 2. So plus or minus 1, plus or minus 2. What are factors of 3? Plus or minus 1, plus or minus 3. Good news is that's all of them, right? Okay. My recommendation is list them out so I know what all my possibilities are. This will be important for the next step we're getting ready to look at. So, factors of -2. We had 1 and 2. I'm going to say 1 over 1, plus or minus 1. 2 over 1, 2. And then I'm going to say 1 over 3, plus or minus 1/3, and 2 over 3, plus or minus 2/3. Those right there are my PRRs. That's step 1. Those are possible places that I could have solutions. Possible places my graph could cross the x-axis. Now, the way we're going to figure out which ones work is synthetic division. Now, how many possible rational roots do I have right now? 4 numbers, 2 signs each, so we technically have 8, don't we? If you think about +1 and -1, those are 2 different numbers. We have 8 possibilities. Do you want to do 8 rounds of synthetic division? Probably not. Okay, so we have a different plan. And this is where I'm going to have you check the graph to get yourself started on these problems. Okay? Your best graphing utility is Desmos, right? So if you have a graphing calculator, however you want, you need to look at the graph of this and see what it looks like. And I should have gotten this ready on Desmos. So graph this, the provided equation.
Come on. Yes.
Why does it have to do this? There we go, graph. Wait, so we just type in that their number?
Yep, you're just typing in that graph.
Should I still do it, or are you just? look at yours.
It doesn't matter.
I'll do the second one. I'll do the second.
Okay.
I'll go ahead.
Why does it look like
Well, because it's an x to the fourth is why it's kind of funky down here.
Wait, how do I?
So, okay. You may or may not be getting yours done on Desmos, but this is how I suggest you graph them in homework. Now, on my other screen, you have your notes in front of you. We had PRRs listed, right? Those were possible rational roots. So those were possible zeros. When we talk about possible rational roots, those were possible zeros. Those numbers you listed, do they match up with any of the zeros here? As in, too bad I can't draw on here, but right there,
Wow.
Yes.
okay, and right there. Now, this one definitely looks like, the one to the left definitely looks, I didn't even touch that, wow. That definitely looks like -1, doesn't it? Okay.
You press the plus on your.
Okay. This one to the right. It's bigger than 0,
But it's smaller.
smaller than 1. Think about your options on the list. We had plus or minus 1 and 2.
2/3.
We had 1/3 and 2/3. What's your guess? Is that 1/3 or 2/3?
Probably
I think
two.
it's
1/3.
Nope.
You say 2/3?
Yep.
I don't know.
Okay. Now, and here's the thing. It's a guess. I would say it's closer to 1, so it's going to be closer to 2/3. But this is what we're looking at here, right? Okay. So this is how you're going to use Desmos to figure out where's my graph cross the x-axis.
That's my.
It looks like it crosses at -1. That's a pretty definite.
Touch
And probably 2/3.
I didn't even tell you.
The thing is, it's not going to tell me 2/3.
Oh,
You gotta say like zero.
Oh.
Yeah. That's.
It's going to give you a decimal.
but
2/3.
1/3 is 0.33, so yeah, it's 2/3.
Okay.
Told you.
So,
Got me there.
I already got it.
so what I'm going to write here is I'm just going to, so what I'm going to put here, that's not what I meant to put, oh well, is to check the graph on Desmos or however you want to graph it. Okay? So check the graph on Desmos for PRRs. In this case, the values we spotted that we're going to try are x equals, what do we say, -1 and positive 2/3, right? I got that by looking at my graph. And if I put a little sketch over here, it's the idea of, well, that's not very, it looks something like this. And the idea, so you have something to look at in homework, that looked like -1. And this one, we think looks like 2/3. I mean, it's a pretty legit, it's a pretty solid guess there. So this is what we're going to use to get our values to check. Or if you prefer, synthetic division and check all 8, right?
No.
I'm going to go with Desmos as going to be a quicker route when you're doing this on your own.
Now on the homework.
Now, okay, so step 1, we found our PRRs. We found the list. Step 2, we went to Desmos. We checked to see which ones we would want to use. Okay? Okay, step 3, we need to check the ones we just decided look like they're going to work. So, we decided that it looks like -1 will work, yes? So we're going to check -1 using synthetic division. You know how to do synthetic division, right?
Mm-hmm.
-1 goes in the box. What numbers are going to go next to my box?
3, 4, 2, -1, -2.
Okay. There's my synthetic division that we're checking, right? Checking, what do we need? If this works, what do we need to happen? At the end, how do we know it works? if there is a
No remainder.
remainder of 0. Okay? So, practice this again. Drop the 3, multiply. Negative 1 times 3, negative 3. Add 4 plus negative 3,
1.
1. Multiply. Negative 1 times 1,
No remainder.
negative 1. Add 2 times negative 1, 1. Multiply. Negative 1 times 1, bless you, negative 1. Add negative 1, negative 1, negative 2. Multiply. Negative 1 times negative 2, positive 2, add, and we are at 0. So what do we know? Negative 1 worked because we got a remainder of 0. Next, we had another one to check in this example, right? Gentlemen, just do the notes. Rather than take a nap, do the notes.
Oh, yeah.
Next one we're going to check is 2/3. Now, hopefully you didn't go too far ahead of me. When I use 2/3 to check it, please listen. Okay. When we use 2/3 to check, it's important because in the end, we want to be able to find our other roots, our imaginary roots. So it's important that we take, instead of using the original row of numbers, we're going to use our new row of numbers. I did this once yesterday, right? So we're going to use, instead of the 3, 4, 2 row, we're going to use this 3, 1, 1, negative 2 row to help us factor it down. So it's important that you use your updated row of numbers.
Oh, man.
So 3, 1, 1, negative 2. Now, I know the fraction looks scary. However, if it is truly works like it's supposed to, it's not scary because the numbers are going to be nice. Guys, 2/3 times 3. Here, look at this. 2/3 times 3. 2/3 times 3 over 1.
6 over 3.
3's cancel. Oh, I say 3's cancel. My answer is 2. Aaron said, or someone said 6 over 3, but 6 over 3 is 2. Okay, so drop the 3. 2/3 times 3 is 2. 1 plus 2
Wait, doggone minute.
is 3. Hey, guess what? 2/3 times 3? 2 again. 1 plus 2 again? 3. 2/3 times 3 again? 2. Negative 2 plus 2.
3, 3, 3.
0.
0.
Oh, 3.
Okay. Now, listen up. 0 worked, or 0's a remainder, 2/3 works. So what we know right now, okay, because part of this you have to have a factored form, with the 0 of negative 1 working, what is that represented as a factor? That is x,
Plus or minus?
which one?
Plus or minus 1.
But if it's negative 1, we say x
Oh, it equals. Yeah.
plus 1.
Yep.
Okay, so that's one of my factors. 2/3 is going to be x
Minus 2 over 3.
minus 2/3. Okay, those are my factors that we're going to use here in a moment when we give our answer.
Wait, we're not even done?
Well, we technically have one more piece because here's the deal, guys. This is 3x to the 4. How many answers do I need?
4.
4. Now, my graph only showed 2. It showed my 2 real ones.
Oh, God. Now the eyes.
Now we've got to find our 2 imaginary. So,
We don't have to. Let's just not do it.
I'm writing
enough
tight.
time for the next one.
Okay, listen. My 333 right here. What does 333 represent? It's 3x to the
Well, here, give me a doggone moment. Wait, 2. 3x squared
3x squared plus
3x
3x
plus 3.
plus 3. right? You can go back and look at, this is originally 3x to the 4th. Then if that was 3x to the 4th, we divided out, that was 3x cubed. So if this is 3x cubed, this is 3x squared, right? So here's what we have to solve, guys. We have to solve 3x squared plus 3x plus 3 equals 0.
Oh, doggone.
Oh my gosh.
The
we have
answers? The answers are going to be imaginary, so it's not going to factor. What's my game plan?
to
So
PAC.
just leave it where it's at.
No,
Or could you do quadratic formula?
we have to do quadratic formula. Okay, hang with me. We can do this. You guys can do quadratic formula. Yes, you can. Okay. X equals. Oh. Do you want to use the 3s or do you want to make this a little easier?
Oh,
Easier, easy.
Okay. What do you notice about everything in this equation? You can divide all by 3. Is it an equation?
Sure.
Yeah. Does it equal 0? Can you divide 0 by 3?
Absolutely.
So if I divide everybody by 3, what's this equation become?
X squared
X
plus
squared.
X plus 1.
that means you don't have to use quadratic formula.
Disagree.
Oh.
We still have to use quadratic formula, but instead of using 3s, you can use a little bit smaller numbers and use 1s. Now, can you use the 3s to get it to work out?
Yeah.
Yes. If you've already started, you're using 3s, you'll just have to reduce at the end.
Yeah.
So, here we go, quadratic formula. Negative b, so that's going to be negative
Oh my goodness.
1 plus or minus the square root, b squared,
Oh man, I just messed that up.
so 1 squared minus 4ac, minus 4 times a times c, which are both 1s, right? So 4 times 1 times 1,
That's 4.
all over 2a,
2.
which is 2 times 1. So, negative 1 plus or minus, okay, 1 minus 4 times 1 times 1.
It's just 1 minus 4, which is negative 3.
Okay?
Over. Alright.
What is the square root of negative 3?
Joe.
I
Okay?
square root of 3.
So that square root of the negative is an I out front. Square root of 3 I can't do. So this is going to stay x equals negative 1/2 plus or minus I square root of 3 over 2.
Oh, Lord.
Not pretty, is it?
This at this point, if I had this as my answer, I'd be like, oh yeah, that's wrong.
But it's right.
But it's wrong.
Okay, so it said all complex roots. Part of my answer is negative 1/2 plus or minus I square root of 3 over 2. How many answers is that right there?
That's
2.
2.
That's 2. One with the plus sign,
Holy cow.
one with the minus sign.
It's mine.
What were my other 2 answers?
X minus 2 over 3 and x plus 1.
Well, those were my factors, but so the
Oh,
answers,
so they're not the answers. Got it.
Negative 1.
okay, so the numbers we used for synthetic division, those were my zeros, my roots. Negative 1 and 2/3 were my roots,
It's mine.
okay? The other 2 we found right here are complex ones, the negative 1/2 plus or minus I square root of 3 over 2. That right there are 4 roots. Now, depends on the question in homework as to what they're asking. Right here, if they're asking for the roots, this is what we're going to give. If they're asking for the roots. And I kind of don't have room to write the other part. But, well, officially it says if they ask for factored form was not -1, but it's x plus 1. In other words, if you put it back in factors, 2/3 as a factor is x minus 2/3. Okay, sorry.
So wait a minute, these are just the roots?
Still a room.
Okay, I know, I don't have room either. I'm struggling.
I'm excited to do the next one.
I bet you are.
Now, the other factor, guys,
Oh,
I would not put this, no, listen.
sorry.
The other factor, I would not put this in a factor. I would just go back and grab this right here, which is the
Oh,
3x squared plus 3x plus 3.
Is that our final answer?
Okay,
that is.
so
Yeah, that's funny, right?
we have two different answers here. This is our factored form. This is our roots. It depends on which question they're asking you.
That is. Yeah.
Okay?
I like the top one a little bit.
In some of the homework questions, I can't remember exactly which ones I picked, they might just ask you for the roots. So you might just say x equals -1, 2/3, and the other one. In some of your answers, problems they might ask for the factored form. So that is the x plus 1, x minus 2/3, and 3x squared plus 3x plus 3. In some of your problems, they might ask you for both. I don't remember exactly what the combination was there. Okay?
That's a good day.
Oh, yeah, you have no idea what you just missed.
Yeah.
You're gonna be thanking me
Now,
for trying to keep you awake.
Here's what I want you to do. So we have 4 minutes left, right?
Nope, we don't got time.
We definitely don't have time. But can you start
Homework.
finding your PRRs
And homework.
and look at the
Oh.
graph?
You mean right now?
I'm talking about this one right now.
No. That's what
Oh, I already did that.
Don't got enough time.
Okay?
I'm like,
Because that will get us going for tomorrow.
Y'all get on that.
I'm already on
You doing that?
the expedition.
Okay. So we'll pick up here tomorrow. We'll have to do this one, and we'll have to look at the ones on the back and go from there. Homework is out there and available. You know how to do part of them you don't know how to do.